Hello all, we're going to get started. So I would request all the judges to come and take seats, and everyone please get seated. So we're going to quickly get started. My name is, for those who are watching via live stream, thank you. And those who will be sitting and watching this YouTube video on their own leisure, also thanks for coming and watching us. So my name is Dr. Karthikeyan Umapati, the co-director for this FL Data Science for Social Good program, and welcome to this 2025 AI Hackathon. We have 11 teams presenting. Each team will have 10 minutes. For all the presenters, we want you to stand in this corner the way they are standing, and when you're speaking, please exchange the mic to speak. So presenters got 10 minutes to present, and judges got 5 minutes to ask questions, and only judges can ask the question. Right? So with that, I'm going to transfer the stage control to Dr. Dan Rishad. He will be managing the stage, and Dr. Indika Kananda will manage the time. So he's sitting there for all the presenters. He will be showing you when your time is up. So with that, good luck to everyone, and I'll let the Dr. Rishad to manage the team presentation.
Yes, thank you all for being here. Dr. Kanda is going to keep time, and then I will be the heavy. So if you don't stop presenting, then you expect a visit from me. So our first team up is called GIT Happens. I'll have them introduce themselves and get started on their presentation.
Good afternoon, everyone. We are Team GIT Happens. I am Anjali, this is Cibi, and this is Beauti. And our project is Homeless AI for Affordable Housing Equity. We chose the problem number 3, that was strategic recommendation for affordable housing investment. So Jacksonville's population has been growing fast, about 9% in the last decade, while rents have gone up like 50%. And at the same time, there's a nationwide shortage of affordable homes for low-income renters, which means more people are competing for fewer places to live. Now, local officials have to deal with displacement, tight budgets, and subsidy programs scattered across different agencies. It's hard for them to see at neighborhood level where affordable units are at risk or where support is most needed. So our goal was clear. It was to give Jacksonville a simple tract level signal and map to show exactly where to preserve and invest first. And that's why we chose this problem, to help the city use its housing funds wisely and protect neighborhoods most at risk. Our solution is the IPS, called the Index of Preservation and Stress, which shows how much housing pressure each neighborhood is under. So we combine 4 ideas, that is affordability stress, economic vulnerability, equity impact, preservation risk, and we scaled each from 0 to 1 and weighted them. And we weighted them as 30% for affordability, 25% for economic, and 15% for equity, and 30% for preservation. The higher the IPS, the more attention that track needs. Then we mapped it where, the green means it's for low risk, and the red means it's at very high risk. The higher the IPS, the more attention that track needs. And we also trained a small AI model to show which area needs more action and which area needs more action. Now Cibi will take over from here.
Good afternoon, everyone. So let's now talk about how we actually built this system. So we started by bringing together data sets from over 20 cities, US cities, covering housing, income distribution, subsidy expirations, and social equity. Each data set came in a different format, So the first step was to standardize and merge them into one unified structure for each city, focusing on four main themes: affordability stress, economic vulnerability, equity, and preservation risk. Next, we built an investment priority score, or IPS, which measures how urgently a neighborhood needs attention. We used random forest model not just to predict, but to learn which conditions most strongly influence housing distress. Then we normalized all those features, things like rent burden, minority share, and income gap, so every neighborhood could be compared on a fair scale. Once the model was trained, we visualized its output through maps and heat maps, allowing city leaders literally see where affordability is collapsing. We also explored adding migration data like IRS and USPS data to understand how population shifts, such as people moving from higher income states to Florida, are affecting local rent prices and availability. Though we couldn't fully integrate that within the time frame, it's highlighted a critical link between migration and affordability pressure. Finally, we built a suggestion-based framework that recommends specific tracks for investment or subsidy renewal. In short, the model doesn't just find problems, it gives city a clear data and direction on where to act first. Data was structured more than 40 data sets, many of which had missing or inconsistent in some like lead exposure or REAC quality scores where income using proxy variable to integrating IRS and USPS movement data to capture how population inflow, especially from higher income states, is putting pressure on Jacksonville's affordable housing stock. It gave us a valuable insight into how population mobility directly affects affordability. Another challenge was finding the balance between technical precision and real-world activity. We wanted our model to be rigorous enough for data scientists, but simple enough for city planners like you and community leaders to actually use. That's where our biggest learning came from. The data alone doesn't solve the problem. It's the story behind the data that helps decision makers act. Visualization tools like heat maps and IPS maps help translate thousands of rows of data into something everyone can understand. And I have added a picture of a chatbot where if you give a tract ID, specific area and what the score of each area is. Not in zip code level, but it's ID from the neighborhood and tell what has to be implemented and how it has to be implemented. For example, we have taken a random geo ID. I'm going to tell you what the score is, and it needs urgent stabilization and preservation focus and what to do in it. Right to counsel or anti-eviction legal support for renters here. Invest in lighting, sidewalks, safe bus stops with affordability, and fund tenants, education or organizing so residents know their rights, and many more. So we have way more to go with this bot, and it's gonna need more data from all the city neighborhoods. On to Beauti for the performance results.
Now that we have built the analytical foundation, let's look at how the model actually performed and what it revealed about Jacksonville housing landscape. So we began by bringing together housing data from 25 cities across US, covering more than 4,500 census tracts. For each tract, we created something called IPS, and they have already explained what IPS is, so I'm going next. So we trained a random forest model to find pattern behind this score and then used a SAP explainability to understand which factor mattered more. It explained almost 87% of the variation in housing stress across neighborhood, a very strong predictive signal. So the results were clear. The affordability burden, minority renter concentration, and low income areas showed up, and subsidy expiration risk also. So in Jacksonville especially, the model identified urban core and northwest Jacksonville, which we can see in color red, very high risk. So you can see the green map there, which visually ranks the city at low risk, and green to yellow, then orange, and then red. For example, where to the orange, the red one means very high, which means where to, sorry. The red one means where to implement the subsidy and all those things, affordability and for household and neighborhood. At the top right, this is the color grid or the heat map, which shows, which validates the relationship between those risks. Each colored box compared two conditions like rent burden, income, and minority concentration. The red boxes show where two problems occur together. For instance, areas which with high rent burden, and the blue boxes shows where one improves as the other worsen. So our model isn't just spitting out numbers, learning from and validating the lived realities of Jacksonville neighborhoods. From these results, we can draw some important conclusion and policy direction. First, housing stress is predictable and measurable. That means the city can take preventive action instead of reacting to crisis after families are already displaced. Second, our housing investment priority score can pinpoint the highest risk early, helping agency and planner focus on their limited budget where they have the greatest impact. Third, their result align with Jacksonville actual housing realities. Neighborhoods near the urban core and northwest areas consistently show the strongest need of equity-centered investment. So the broader community impact is equally meaningful. We can prevent displacement before it happens, strengthen the neighborhood stability, and ensure the resources that are distributed fairly where they needed most. Especially this project transformed raw data into roadmap of equitable housing policy. This chart shows factor which matter the most. The affordability stress is the top predictor, followed by economic vulnerability. By using this framework, Jacksonville can take informed proactive action, protecting affordable homes today and ensuring a more stable and inclusive housing future for tomorrow. Thank you.
Now we'll have 5 minutes and questions from our judges.
I was curious on the dimensions that you're showing, the economic vulnerability and the other three. Where did those dimensions come from? Are those ones that you guys created, or was that in the data set already?
Those were in the data sets already, which was given to us.
Could you explain just a little bit about what's behind them?
What's behind the economic vulnerability? So the affordability stress is where in Jacksonville, if you go to North Jacksonville, most of the people have their 30 to 40% of their income just for housing, just to stay in the areas. So if it goes up by 10%, then they are in economic vulnerability, which will also go up. Because then if let's say their Medicaid is going up, or they have any emergency expenses, they are in more economic vulnerability. So the equity impact is how much they can save up for their living, which can cover up to the next month. And the preservation risk is, if all those things happen, then the preservation risk is gonna go up. It's gonna mean the area is not sustainable for them. They had to move to a different area, which potentially means losing their jobs, which they are doing in the particular area.
Thank you.
So, based on those factors, how did you determine the weightings, and what did you use to normalize? What approach did you use to normalize for your score?
What approach do you use to?
You said you normalized the data.
Mm-hmm.
So how did you normalize the data for your weightings?
Because we did not.
What approach did you use to normalize?
We used random forest method to run the data on all the 25 cities which we got.
Okay, but you normalized it, right, to create your score?
Mm-hmm. Yes.
So what approach did you use to normalize?
The IPS score.
Yes.
That's taking in concept of the affordability index plus the median income, and other thing was the preservation risk equity. Sorry.
And then the results of your bot below, how are you proposing, I'm sure you can have time to do it here, but how are you going to QA the results, or how are you going to assure that the results coming back are valid results?
The results coming back are valuable results.
Valid.
This
Yeah, from the bot section that you're
from the this.
Yeah, how do you QA and make sure that the results coming back aren't
Because this,
hallucinations or they're
the random forest model knows because we tagged the geo ID with the tract from the US federal website, and we tagged each shape to the neighborhood, and we rated the neighborhood with an IPS score. So it's gonna show from a 0 to 1, it rates the IPS score first, and then it takes what is the equity impact in that area. So it's not 100% accurate. It's gonna be accurate when we train it with more neighborhoods in the coming days.
Hey, well done. Well done. Quick question for you on that previous slide around exploring additional data sources. You talked about the migration sources of data that, in this day and age, obviously in Florida and Jacksonville, it's broader than just one city. So what do you think you should do to expand on that? Like if you had time, what do you think you would do with that additional data source?
I would definitely consider the USPS option has an option where we can take data set from them, which will tell which zip code has been relocated or which zip code people are moving to and from. So if we have that data, we could see where the people are coming from which city to which city they are moving from. Let's take you are moving from California to Florida. You're gonna change your postal address from there. So they have the data sets. We can use that. And the next is IRS migration data, which gives the tax which people pay to each state, and we'll know what their income is, and we can rate them, and we can determine how their income is going to affect the housing prices here.
Great. Nice job. Thank you.
Thank you.
Great presentation. What partnerships do you envision you're going to need to do, whether it's with the city, nonprofits, et cetera, to further grow the IPS and make it, a stronger, more, better, program to be updated in real time?
As of now, I'm not sure what all the policies the city has and what policies can the city influence in the coming days, or what they can do now. And the first thing is how much fund they can actually provide to a neighborhood, or how many people they can save, and how much SNAP fund or whatever we have. And the second one is there any way we could, and where to ask for the funds, and how to ask, and whom to approach. Like we can just talk about it within ourselves, but there should be a system where we can do a petition and make sure the petition goes to the right person.
Is there something outside of funds, though, that maybe working with nonprofits on community data for certain neighborhoods like Durkeeville versus Arlington versus, Ortega, to include that data into this model to make it more effective?
So currently I'm working on a college project which is based on food recommendation, which we will get a data where people who cannot afford food would come there and get food and go. So maybe I'll try to do something with that, knowing which people need the most money to go to.
Food bank data and stuff like that. Yeah, absolutely. Thank you.